order to solve inequalities with modulus, there are usually two types. Okay, the first type, if there's only modulus on one side. So recall, if you have modulus on one side only, again it is this concept: modulus x greater than k, x greater than k, or x less than negative k. Modulus x less than k, then it is a in-between inequality, negative k to k. If you do not understand why, check out the previous video where I talk about the modulus x less than k kind of graph. Okay, so for this, we can either use the graphical method or the algebraic method. So graphical method is simple. So all you need to do is to plot y1 equals to negative 2x plus 3, y2 equals to modulus 3x minus 1. So I am just going to plot this without using GC first, okay, to show you that, okay, what idea do you have? You should have in your head. Number one, y1 is pretty simple because negative 2x is a straight line going downwards, okay, and I'm going to use red, and it cuts at 3. Okay, so this guy is called y equals to negative 2x plus 3. It is also good to find out what is the y-intercept. That means when x is equals to 0, just look at your equation. Sorry, when y is equals to 0, and when you can do mentally, the x coordinate is 3 over 2. Okay, so whereas for y equals to modulus of 3x minus 1, I want to tell you that the apex, right, the V shape, will always be when this is equals to 0. So x equals to 1/3 is the V shape. 1/3 is probably over here. Okay, now the graph has a more steep because it cuts at 1. And why doesn't it cut at negative 1? Because it has been reflected upwards already. Okay, and then this guy is going to be over here like that. So y is equals to modulus 3x minus 1. Okay, so now I am using graphical method. The most important critical point are the 2 point of intersection. So I can use my second function calculate to find out these 2 point of intersection. Okay, and then since the question wants the modulus graph to be smaller than the straight line graph, I am looking at the region that is over here. So I'm just going to use my GC. Okay, in fact, I'm going to teach you how not to use your GC to find the graph instead. So look at the blue graph, y equals to modulus 3 minus x. So I want you to know that if you have modulus 3x minus 1, this consists of two graphs. One is 3x minus 1, and one is the negative of 3x minus 1. Because if modulus x is equals to a certain value, x could be k or negative k. Okay, when x is greater than 0, when x is less than 0. So in this case, this is when x is greater than 1/3, and this is when x is lesser equals to 1/3. Okay, so for the right side one, for this graph on the right side, which I'm going to use green, we are talking about 3x minus 1. And I'm going to equate to the red graph, negative 2x plus 3. And when you bring over, you have 5x equals to 4, x equals to 4 over 5. Okay, and then the other way, the other side, the blue one on the left side, here, okay, is talking about the negative of 3x minus 1 equals to negative 2x plus 3. Opening up, negative 3x plus 1 equals to negative 2x plus 3. Negative x equals to 2, x equals to negative 2. So I know that the important points of intersection are negative 2, as well as this guy is 4 over 5. And therefore, my final answer is x is in between negative 2 to 4 over 5. Let me just check, can it be equal? The question is not asking for equal, and that is your final answer. Okay? Now, if the question is asking you to do in a non-algebraic way, in a non-GC way, or rather in an algebraic way, negative 2x plus 3 smaller than modulus of 3x, or rather I think it's the other way around. Yeah, greater than modulus of 3x minus 1. Okay, we go back to the basics of this concept. Modulus x, in this case, the modulus is smaller than k because can you see the inequality sign is this way? The back side is pointing to the modulus. I am talking about x in between negative k as well as k. So I can say that 3x minus 1, this is kind of like the modulus x. This is like the lesser, and this guy is like your k, is in between negative 2x plus 3, the positive one, as well as the negative of negative 2x plus 3. Okay, the negative one. So I'm going to open up. I will have 2x minus 3, 3x minus 1, a negative 2x plus 3. Do a simultaneous inequality. So take this side. I'm going to get, so if you take this side and work it out, you are going to get x is greater than negative 2. Okay, and then if you are going to take this side, okay, and work it out, you are going to get x less than 4 over 5. And when you combine these two, now some students cannot see the combination of these two, then it's good for you to draw out a number line. Greater than negative 2, this way. 4 over 5, lesser than 4 over 5, this way. Overlapping region is here, so therefore, x is in between negative 2, 4 over 5, and it should be the same result if you do it on a graphical method. Okay, so understand that the modulus graph is made up of two different graphs. When you modulus, one is the positive one and one is the negative one. And you can use your graphic calculator to find the point of intersections. Okay, but if the question is asking for exact form, which means you need to either use the algebraic method, that would be a better way to work it out, and then you can find the critical region, that part that the two inequalities overlap. I'm going to talk about a few more advanced techniques in inequalities, especially when it comes to modulus. Okay, so let's say you have like two answers like this. The first answer is modulus x less than 4, then and then you have another one which is greater than 0 and lesser than 2. Okay, so for this case, you have to know immediately I'm talking about x must be in between negative 4 to 4. If you're still not very quick with this concept, please look at the front video to internalize that if you are lesser than k, it's in between. If you are greater than k, it's the left and the right region. Now, whereas for this, it's quite important you split it up again. So modulus x greater than 0. All modulus x are greater than 0. So the answer for this is x can be any real number. Okay, if you don't understand why about this, is because if modulus x is greater than 0, I'm talking about x greater than 0 or x less than 0. Now, when x is greater than 0 and x is less than 0, on the number line, we are talking about this part to the left, less than 0, and this part to the right. So it encompasses any values that is over here, except for the value 0. So 0 cannot be counted, and this is how we put in except. Okay, except. So yeah, when modulus x is greater than 0, we are just talking about any real number, but be careful because the inequality sign says it cannot, I am not equals to 0, or I cannot include 0 as well. If I'm going to just take this part, modulus x less than 2, it means that x is in between negative 2 as well as 2. So I'm going to label negative 2, 2, and this part is just talking about here. Okay, and for I need to combine with the first part. The first part, which is from negative 4 to 4, I'm going to use green negative 4 to 4. I'm going to get this part, but you realize that it doesn't matter. Now, where is the part that it all overlaps? Okay, you can see that it's going to be this part here. I can include this part, doesn't matter, but it doesn't hit 0, you see, as well as this part over here, and it doesn't hit 0 because x cannot be 0. X must be strictly greater than 0. Yeah. So how do I present the final answer? You can do it two ways. So you can look at this part as, okay, I'm going to use my yellow highlighter. This part as one region, which means that x is greater than negative 2 but less than 0. Okay, or x greater than 0 but less than 2. Okay, you can present it in this way. Now, in the more set notation form, we can say that it's a set x is any real number, okay, such that, okay, x is in between negative 2 and 2, okay, but this set exclude the value 0. Okay, this is called exclude. You cannot say it's equals to 0. So you have to use this to exclude it. And this is how some questions may present it in this way, that you must understand that, oh, this sign means exclude. Okay, cannot be. Okay, so this is a more advanced question when you have a simultaneous inequality with a modulus function, as well as when it involves 0.